Hi guys, this is Sourav and welcome to another session for Online Pathshala. This is the first session of electrochemistry and until now we have covered the topic of liquid solutions. Liquid solutions के topic को हमने काफ़ी अच्छे से किया है and we have also discussed some questions on the level of mains and advanced, and that will be the same line on which we will be covering electrochemistry as well. Electrochemistry जो है ये if you take all the topics of physical chemistry, it turns out to be the most challenging topic. Challenging because electrochemistry को master करने के लिए you have to master a number of things. You have to master mole concept, you have to master ionic equilibrium, you have to master chemical equilibrium, thermodynamics. So all of these topics, all of these individual topics का निचोड़ निकल के आता है electrochemistry में. And ऑल्सो इलेक्ट्रोकेमिस्ट्री थोड़ा सा डिफिकल्ट इसलिए लगता है क्योंकि बहुत सारी चीज़ें आपको कंसेप्चुअल इसमें आ जाती हैं. ओके, सो हेलो गाइज, हेलो विवेक, हेलो तलन. सो यू आस्क एनीबडी, कोई भी 11th स्टैंडर्ड कोई भी 12th स्टैंडर्ड स्टूडेंट को ले लो, या somebody who has gotten into IIT or somebody who has qualified any engineering entrance examination or medical entrance examination, if you ask them that which topic in physical chemistry did you find the most difficult, the uniform, like about 95% of people would say electrochemistry. Okay, so this topic is not that very difficult, and we would try to make sure that we do it in a stepwise manner so that it becomes as easy as possible to you. Okay, so this is so try and understand what happens throughout the session, and जैसे जैसे सेशन आगे चलता जाएगा you would be able to understand कि what electrochemistry is all about. It's not a very difficult topic, however it is conceptual, but conceptual है तो अच्छा है. अगर theoretical ज़्यादा रहता and if you had to remember a lot then बहुत मुश्किल हो जाती. Okay, so it's a new topic. Please remember that there are a lot of students who come from certain parts of the country who do not have very good fluency in Hindi. कुछ एक बच्चे आते हैं जो कि जिनको हिंदी आती है. So I'll be mixing both of these languages. So I would request you to not put it upfront as a request that I have to use only English or Hindi. I have to mix both of them so as to make the right डिसीजन फॉर. और आप ये सोच सकते हैं कि मुझे दोनों को बैलेंस करना होगा. ठीक है, सो लेट्स start today's session. But before starting today's session, I just want to request you guys that please join the Telegram group, because awesome amount of people are over there discussing questions, discussing whatever concepts, discussing doubts. A lot of teachers are also over there to help you out. And please do like, share and subscribe our channel so as to be updated with all the awesome content that comes up in future. Okay, we have a plan of bringing up amazing stuff. Pahul sir is gonna do that, Pulkit sir is gonna do that. Please do like, share and subscribe so that to be updated with everything. चलिए स्टार्ट करते हैं इलेक्ट्रोकेमिस्ट्री को. इलेक्ट्रोकेमिस्ट्री टॉपिक हमें पढ़ना क्यों चाहिए? What is the need for studying electrochemistry? If we look around ourselves, let's move out of books. If we look in the nature, there are so many things which are happening around us which involve concepts related to electrochemistry, which involve electrochemical reactions. What are those processes? जैसे कि first process आप देख रहे हो, the first process that you're seeing over here, if you could identify what is happening, can anybody tell me what is happening over here? The first thing, can anybody tell me what is happening over here? The first picture that you can see, there's sun and there is leaf and the clouds, rain and all. ये देख के क्या लग रहा है? This looks like photosynthesis. Photosynthesis, as plant is growing, and photosynthesis is a process. Photosynthesis is a process in which light has been taken in, carbon dioxide and water interact with each other to produce glucose in the within chlorophyll. इसमें बहुत सारी चीज़ें जो हो रही हैं, वॉट एवर प्रोसेसेस आर हैपनिंग विद इन photosynthesis are a part of electrochemical reactions. Okay, are a part of electrochemical reactions. Second चीज को देखते हैं. Are you seeing this? There's a railway track and there is some kind of a furnace over here. There's a furnace. Okay, and there's a railway track. What is happening over here? People who are from Mumbai, okay, people who are from Mumbai might have seen this happening on the railway tracks. कोई भी अगर railway tracks के आसपास किसी ने देखा होगा ये चीज होते हुए. This is a process known as thermite reaction. Okay, this is a process known as thermite reaction. This is a reaction. इस reaction को हम करते क्या हैं कि let's say a railway track breaks down, crack develop कर जाता है, तो उस crack को repair करने के लिए what we do is we bring a furnace, we put Fe2O3 and aluminium and we ignite it with magnesium powder, and this reaction generates molten iron. Okay, the reaction generates molten iron which just cements the crack. Okay, just repairs the crack. हम कहीं से furnace से उठा के हम iron को ला नहीं सकते हैं, so we carry this furnace with us. Okay, this is a mobile furnace. So this process, thermite reaction is a electrochemical reaction. Thermite reaction is a electrochemical reaction. Now you might be interested in knowing a very important historical fact about thermite reaction is that if you know that ships which are being used in naval warfare generally are made up of aluminium. Okay, क्योंकि उसको light रखना होता है. Now many a times what happens is that if somebody wants to destroy that this ship, they fire a torpedo at it, and the torpedo is made up of a material which is full of iron, and that will start a thermite reaction that will just melt it the moment the impact takes place. So thermite reaction is an example of electrochemical reaction. Third picture is rusting. Rusting is conversion of iron into iron oxide. Okay, iron into iron oxide, and ये जो process है, this is again a electrochemical reaction. So यहाँ भी electrochemistry का use हो रहा है. And fourth, battery. Very simple example. Battery के अंदर जो भी चीजें हो रही हैं, we will be discussing in this chapter, and the concepts, whatever we would be learning, are applicable to whatever happens within a battery. Okay, charging and draining, we take a battery को recharge करते हैं. क्यों होता है, कैसे recharge किया जाता है, what happens, what is the role of whatever is present inside the battery, what is the notation of a battery, we will be discussing that. And commercially available batteries जो होते हैं उसमें electrochemistry का use होता है. Okay, so with this thing in mind, let's try to understand what is electrochemistry. Electrochemistry, yeah, this is Anjana. Anything which is for mains is for advanced. Okay, so please focus on the session. Electrochemistry is a branch of science which talks about, or which takes into consideration, which tries to relate the conversion of electrical energy into chemical energy, or chemical energy into electrical energy. It talks about the relationship between electrical energy and chemical energy and उसके interconversion के लिए. So there is electrical energy which you know is constituted by the flow of electrons, and chemical energy क्या होती है, जो कि reaction होने के कारण हमें मिलता है. Okay, so electrical energy and chemical energy के का relationship and their interconversion is studied under electrochemistry. Okay, now if we take a this looks like a battery, and यहाँ पे आप देख रहे हैं कि bulb है. Now this bulb is in a switch off mode, and when it turns yellow it's in a switch on mode. So this process, what is happening over here, हम इस battery which involves a chemical substance within it, उस chemical substance से chemical energy abstract कर रहे हैं, and that chemical energy is being used for generating electrical energy. So from any battery, okay, any battery, when we are trying to obtain electrical energy that involves the study of electrochemistry. Another process that we can see over here, can anybody identify? ये बहुत ही simple process है. हम एक battery use करके we are trying to perform something known as electroplating. Okay, electroplating. Electroplating is also a process where electrochemistry is studied. So what we are doing, electrical energy use करके हम chemical reaction कर रहे हैं. Okay, we are performing chemical reaction using electrical energy. ये सारे processes आप देखते हो अपने about, many a times they are very much visible, many a times they are like late and invisible रहते हैं, लेकिन ये सारी चीज़ों में हम electrochemistry को involve करते हैं. Okay, so let's talk about कि if I have to convert chemical energy into electrical energy or electrical into chemical, what do we need? किसी भी फॉर्म ऑफ एनर्जी को एक से दूसरे चीज में कन्वर्ट करने के लिए आई नीड अ डिवाइस. ओके, ये इस डिवाइस का नाम क्या होता है? दिस डिवाइस इज नोन एज इलेक्ट्रोकेमिकल सेल. ओके, सो अगर मुझे एक इलेक्ट्रिकल एनर्जी को केमिकल एनर्जी में कन्वर्ट करना है और केमिकल एनर्जी को इलेक्ट्रिकल एनर्जी में कन्वर्ट करना, आई नीड अ इलेक्ट्रोकेमिकल सेल. सो इलेक्ट्रोकेमिकल सेल इज अ डिवाइस विच कन्वर्ट्स. Okay, electrochemical cell is a device which is capable of either generating electrical energy from chemical reactions, जैसे कि बैटरी में chemical reaction से electrical energy generate होती है, so that will become a electrochemical cell, or using electrical energy to perform chemical reactions. That means in electrolysis. So either you take electrolysis or you take a battery which is generating electricity, both of them would be qualified as a electrochemical cell. Okay, okay, both of them would both of them would be qualified as, और दोनों को हम electrochemical cell ही बोलेंगे. Okay, now let's look at what are the different types of electrochemical cell. Electrochemical cells को हम दो पार्ट में डिवाइड कर देते हैं. Okay, we divide them into two parts. One is known as a galvanic cell or voltaic cell, in which we convert chemical energy into electrical energy. Chemical energy into electrical energy. इसका example क्या हो जाएगा? The example of this will be a generic battery. आपका 1.5 वोल्ट बैटरी जो आप यूज करते हो, या फिर आपके मोबाइल फोन में जो बैटरी लगा है, और लैपटॉप में जो बैटरी लगा है, और द कार में जो बैटरी लगी है, या फिर इन्वर्टर बैटरी जो लगी हुई है, ऑल ऑफ दीज बैटरीज विल बी क्वालिफाइड और विल बी कॉल्ड गैल्वेनिक सेल और वोल्टाइक सेल्स. सो गैल्वेनिक सेल और वोल्टाइक सेल्स आर दोज डिवाइसेस जहां पर कि हम केमिकल रिएक्शन यूज करके इलेक्ट्रिकल एनर्जी एक्शन. ओके, दिस इलेक्ट्रिकल एनर्जी इज ऑब्टेन्ड फ्रॉम अ केमिकल रिएक्शन. सिमिलरली एक होता है इलेक्ट्रोलिटिक सेल, वेयर इलेक्ट्रिकल एनर्जी इज यूज्ड टू परफॉर्म और ऑब्टेन केमिकल एनर्जी. जैसे इलेक्ट्रोलिसिस ऑफ वाटर, ये आपने पहले पढ़ा होगा इन 9th स्टैंडर्ड और 10th स्टैंडर्ड. इलेक्ट्रोलिसिस ऑफ वाटर. इलेक्ट्रोलिसिस ऑफ वाटर कैसे करते हैं? वी प्रोवाइड इलेक्ट्रिकल एनर्जी एंड देयर इज अ कैथोड एंड एनोड, एंड एक रिएक्शन होता है जिसमें कि हमें हाइड्रोजन भी मिल जाता है एंड वी ऑब्टेन ऑक्सीजन. सो electrolytic cells involve conversion of electrical energy into chemical energy. So in future, okay, in future, whenever I say voltaic cell or galvanic cell, it means chemical into electrical. Whenever I say in future electrolytic cell, electrical energy into chemical energy. Now, what is necessary for conversion of, हम कैसे बोलेंगे कि कोई भी केमिकल रिएक्शन इलेक्ट्रिकल एनर्जी में कन्वर्ट होती है? व्हाट इज द डिफाइनिंग थर्मोडायनेमिक प्रॉपर्टी? व्हाट इज द थर्मोडायनेमिक्स ऑफ दिस? ये इंट्रोडक्टरी है, सो हम जो भी पढ़ रहे हैं इसको हम आगे और डिटेल में पढ़ेंगे, बट लेट्स गेट एन आइडिया दैट हाउ डज दिस हैपन, और इसमें होता क्या, व्हाट हैपन्स थर्मोडायनेमिकली. So there is a term known as free energy. How many of you know about free energy? So there's a term known as free energy. So this term जो आप देख रहे हो, this is known as free energy change. Free energy change talks about feasibility or spontaneity of a reaction. Okay, for example, water falling from the top of a mountain, water evaporating, a cup falling from my hand and breaking into shards, diffusion of molecules. Okay, diffusion of molecules. All of these processes look like they happen on their own. होता है कि नहीं? Water falling from the top of a mountain, वो अपने से होता है, लेकिन नीचे से पानी ऊपर जाते हुए हमें नहीं दिखता है. Okay, we do not ever see that process happening in the reverse direction. We see a battery supplying energy, we never see that it is getting recharged on its own. Recharge करने के लिए हमें electrical energy बाहर से supply करना पड़ता है. Okay, we never see that. Let's say I take a bottle of perfume and I spray it in a room. I will see that the molecules will spread inside the room, and if they spread inside the room, I will observe, I will feel the fragrance at every corner of the room. कभी आपने ये देखा है कि ये molecules एक जगह पे आके they just coalesce and they come and concentrate in one region? ऐसा तो नहीं होता कि they come back and concentrate inside the bottle. No, you haven't seen that, because there are certain processes which are spontaneous. Spontaneous means they happen on their own, while there are certain processes which do not want to happen on their own. एक सिंपल सा एग्जांपल लेते हैं. मान लो कि एक क्लासरूम है. क्लासरूम के अंदर अबाउट 100 स्टूडेंट्स बैठे हैं. ओके, देयर इज अ क्लासरूम इनसाइड विच देयर आर 100 स्टूडेंट्स हु आर सिटिंग. नाउ अ टीचर कम्स इन. टीचर को देखते ही सारे बच्चे, what will happen? Every kid will like sit on their desk, and also there would be some people who would be making noises. तो टीचर को बोलना पड़ता है कि भाई चुप हो जाओ, चुप हो जाओ, चुप हो जाओ. ये सबको बोलना पड़ता है. So teacher has to put some effort. ठीक है. अब होता क्या है कि बेल बजती है बाहर, पीरियड खत्म होता है, टीचर बाहर निकलता है, एंड बच्चे फिर से हल्ला करना शुरू कर देते हैं. Now tell me something. Which process is more favorable? टीचर के क्लास में आके बच्चों का शांत बैठना, इज दैट मोर फेवरेबल, और मेकिंग नॉइज इज मोर फेवरेबल? ओके, विच इज मोर फेवरेबल? क्या मोर फेवरेबल रहेगा? बच्चों का हल्ला करना ज्यादा फेवरेबल रहेगा कि? सो सेकंड वन, अनित इज सेइंग सेकंड वन, मेकिंग नॉइज इज मोर फेवरेबल. आप अपनी एक नॉर्मल ऑब्जर्वेशन, गोइंग to the playground is more favorable, coming back from there is not so favorable. The first process is not quite favorable. First process में क्या है कि मुझे energy देनी पड़ रही है. Okay, the second process is more favorable. The favorability of a process is decided by something known as free energy change. ठीक है. तो free energy change जो होता है, if it is negative, it means it is favorable, and if it is positive, it is non-favorable. It is non-favorable. Okay, it is non-favorable. So free energy change के दो results आ सकते हैं, if it is positive or it is negative. एक third result भी आता है which is zero. If it is zero, that means equilibrium. Okay, if it is zero, it is equilibrium. So अगर हमने एक process लिया, let's say I take a class and I take a noisy class, quiet class, और हम एक noisy class लेते हैं. Okay, एक noisy class लिया हमने, quiet class लिया. एक noisy class का quiet class में convert होना, is that favorable or non-favorable? Is that favorable or non-favorable? This will be non-favorable. Okay, it is non-favorable obviously, but the opposite thing ये क्या होगी बताइए? This will be favorable. So if I look at two things which are interconverting, उसमें से एक चीज फेवरेबल अगर हुई तो दूसरी नॉन फेवरेबल होगी ही. Okay, so one process if is favorable, the reverse process will always be non-favorable. Okay, this is always gonna happen. This is always gonna happen. So my objective in evaluating the merits or the characteristics of a chemical change is or energy change is to identify which direction is feasible or which direction is favorable. I can very well identify the other one which will be non-favorable. So if it is favorable, for this one delta G will be negative, for this one delta G will be positive. Okay, this will be positive. Within a electrochemical cell as well, one reaction, देखो हम कन्वर्ट किसको कर रहे हैं? इलेक्ट्रिकल एनर्जी इनटू केमिकल एनर्जी. आई एम कन्वर्टिंग इलेक्ट्रिकल इनटू केमिकल. सो वन प्रोसेस विल बी फेवरेबल, वन प्रोसेस विल बी नॉन फेवरेबल. हमेशा याद रखिए कि केमिकल इनटू इलेक्ट्रिकल, केमिकल इनटू इलेक्ट्रिकल इज delta G is less than 0. That means it is favorable. This is favorable. While this conversion has delta G which is positive. So ये चीज आपको याद रखनी है. In future, wherever we would be discussing about chemical converting into electrical, we will always try to identify favorability as delta G which is less than 0. Okay, whenever we would try to identify electrical energy converting into chemical energy, हम delta G को positive कर देंगे. So याद रखिए इस चीज को. इसमें एक बहुत सिंपल सा कंसेप्ट आता है. Let's understand it in this way. Okay, let's understand it in this way. Let's say there is a process. A changes to B and there is another process. C changes to D. For this delta G is minus 120. For this delta G is minus 50. Kilojoule per mole. Okay, kilojoule per mole. Now can you tell me which process is more favorable, the first one or the second one? Which is more favorable? Delta G for this is minus 120, delta G for this is minus 50. Which process is more favorable? A to B is more favorable. So जितना negative होगा, if the magnitude of the negative negative result of delta G increases, it becomes more favorable. This is more favorable. जितना negative होगा उतना favorable होता जाएगा. Okay, A to B is more favorable as compared to C to D conversion. Is that clear? A to B is more favorable than C to D conversion. Now if I take the reverse process, B to A, तो इसके लिए डेल्टा जी हम क्या लिखेंगे? 120. इसके लिए क्या लिखेंगे? D to A C, delta G will be written as plus 50 and this is plus 120. Now which is more favorable? The second one. In the second scenario, which is more favorable? In the second scenario, which is more favorable? Plus 50 is more favorable, plus 120 is more favorable. Plus 50 is more favorable. Very good. So this is more favorable. Okay, so this is a very important idea. This is a very important idea. आगे चल के फ्यूचर में आपको इस चैप्टर में ये चीज बहुत इंपॉर्टेंट आपको हेल्प करने वाली है. Always try to have delta G to be as negative as possible. और if it is positive, तो जितना कम पॉजिटिव होगा उतना फायदा रहेगा आपका. ओके, इफ इट इज एज लेस पॉजिटिव और एज मोर नेगेटिव, Okay, try to remember this. Delta G should be as negative as possible, or as less positive as possible for favorable. फेवरेबल के लिए ये कंडीशन रहती है. ओके, फॉर फेवरेबल दिस विल बी द कंडीशन, एज लेस नेगेटिव और एज लेस पॉजिटिव. ठीक है. सो वेन एवर वी वुड बी डिस्कसिंग इलेक्ट्रो voltaic reactions or galvanic reactions where chemical energy is converting into electrical energy, I would be looking at those values, I would be taking those values as to be more favorable, जहां पर कि डेल्टा जी जितना नेगेटिव है उतना अच्छा है. ओके, जितना ज्यादा नेगेटिव है. बट इफ आई एम स्टडिंग इलेक्ट्रोलिटिक रिएक्शंस, I would be taking those reactions where delta G is as less positive as possible. ठीक है, as less positive as possible. So with this idea in mind, let's try to understand कि किस तरह के reactions हमको कराने चाहिए for observing this change within electrochemical cell. Observing this change within electrochemical cell. So हमारे पास बहुत तरह के reactions होते हैं. ओके, फॉर एग्जाम्पल आपने अभी तक पढ़ा होगा कि वी हैव रिएक्शंस लाइक कॉम्बिनेशन, डीकम्पोजिशन, डबल डिस्प्लेसमेंट, सिंगल डिस्प्लेसमेंट. चलिए हम इन सबका एक एक एग्जाम्पल लिख लेते हैं. ओके, सो कॉम्बिनेशन का एग्जाम्पल क्या होगा? एग्जाम्पल ऑफ कॉम्बिनेशन रिएक्शन, H2 plus half O2 changes to H2O. Okay, H2 plus half O2 changes to H2O. Decomposition reaction, CaCO3 changes to CaO plus CO2. I can write this reaction. I can also write this reaction KClO3. I'm just writing some reactions which are very common. KCl plus 3/2 O2. ये एक decomposition का example हो गया. Okay, this is an example of decomposition reaction. Double displacement, example of a double displacement, the very common example of double displacement is neutralization or precipitation. Silver nitrate plus NaCl changes to silver chloride plus NaNO3, or NaOH plus HCl changes to NaCl plus H2O. Okay, NaCl plus H2O. Single displacement reaction, example I can take as zinc plus HCl changes to ZnCl2 plus H2. Okay, so N2 plus H2 is again a combination reaction. Now इन सारे reactions को हम देख लेते हैं. बहुत तरह का reactions हो गए. So we have 4 different classes of reaction. But of all these 4 different classes of reaction, I have to make things quite simple. And हम सारे reactions को पढ़ नहीं रहे हैं. Our objective is to identify कि इनमें से कौन सा reaction हम लेंगे कि that will function as the one which will generate electricity. Okay. Our objective is to identify that reaction in which electricity would be generated. If I add NaOH in HCl, can I obtain electricity? If I add AgNO3 in NaCl, would I obtain electricity? If I heat calcium carbonate and change it into calcium oxide and carbon dioxide, will I obtain electricity? हमें यहाँ पे इलेक्ट्रिसिटी मिलेगा, कहाँ पे मिलेगा इलेक्ट्रिसिटी? सो टू आइडेंटिफाई दिस, लेट्स आस्क आवरसेल्व्स अ सिंपल क्वेश्चन कि इलेक्ट्रिसिटी के लिए व्हाट इज इलेक्ट्रिसिटी? इलेक्ट्रिसिटी इज द करंट. इलेक्ट्रिसिटी करंट जो भी चीज है, दिस इन्वॉल्व्स फ्लोज ऑफ चार्ज. ओके, नाउ आवर चार्ज पार्टिकल, द चार्ज पार्टिकल दैट आई शुड बी worried about or that I should be concerned about is electrons. हमारे पास इलेक्ट्रॉन्स होना जरूरी है. सो एनी, कैन आई से दैट एनी reaction which gives free electron will be utilized. Free electron will be utilized. If I take so many reactions, whatever are there in chemistry, those reactions which generate free electrons will be involved in generation of electricity. Now free electrons की generation अगर हम कर रहे हैं, then I need to take up free electrons as well. These free electrons would be generated and accepted in a reaction which is known as redox reaction. Reduction and oxidation, redox reaction. So redox reaction if is present, अगर redox reaction हो रहा है, then it will be a suitable reaction for a electrochemical cell. Okay, electrochemical cell. So what we do is we take all these reactions and divide them into two parts. We divide them into redox and non-redox. Redox reactions are the ones which will be involving transfer or movement of electrons, and they are the ones which we will be utilizing for electrochemical reaction. So आगे चल के कोई भी रिएक्शन अगर आपको नॉन रेडॉक्स दिखे, वहां पे इलेक्ट्रिसिटी नहीं मिलेगी. और रेडॉक्स रिएक्शन हम एक सिंपल एग्जांपल ले रहे हैं. लेट्स टेक अ सिंपल एग्जांपल. जिंक प्लस कॉपर सल्फेट changes to zinc plus zinc sulfate plus copper. Okay, zinc sulfate plus copper. What is the oxidation of state of zinc? 0. Copper is plus 2, zinc is plus 2, and copper is 0. So you can see that zinc is undergoing oxidation and copper is undergoing reduction. Okay, one is undergoing oxidation, the other is undergoing reduction. Ever you find it difficult to identify what is undergoing oxidation or what is undergoing reduction, ये number line आप याद रखिए. This is let's say 0, यहाँ पे positive values हैं, यहाँ पे नेगेटिव वैल्यूज है ऑक्सीडेशन स्टेट के. इफ यू आर मूविंग फ्रॉम लेफ्ट टू राइट दैट विल बी ऑक्सीडेशन. फ्रॉम राइट टू लेफ्ट इट विल बी रिडक्शन. ओके, राइट लेफ्ट टू राइट, जीरो से पॉजिटिव जा रहा है. देखिए जीरो से पॉजिटिव गया, so it is moving from left to right. So if it is moving from left to right, it is oxidation. If the oxidation state changes from right to left, so positive +2 to 0, +2 इधर रहेगा, 0 इधर आएगा, right to left move कर रहे हैं, so it will be reduction. तो हमारे पास एक reduction reaction, एक oxidation reaction अगर रहा, this is a similar reaction. Zinc, एक सिंपल सा एक्सपेरिमेंट करते हैं. वी टेक अ जिंक स्ट्रिप एंड वी पुट दैट थिंग इन अ सॉल्यूशन ऑफ कॉपर सल्फेट, एक्वस सॉल्यूशन ऑफ कॉपर सल्फेट. अब आप एक बात बताइए, व्हाट इज द कलर ऑफ दिस सॉल्यूशन? कैन यू टेल मी व्हाट इज द कलर ऑफ दिस सॉल्यूशन? द कलर ऑफ सॉल्यूशन इज ब्लू. ये सॉल्यूशन का कलर ब्लू है, ठीक है. अगर आपने कॉपर सल्फेट सॉल्यूशन लिया, इट इज ब्लू. Now if zinc electrode is dropped in copper sulfate solution, what will happen? Zinc will start changing into copper sulfate, so you will see that this strip thins out. मतलब ये strip का जो thickness है वो कम होता जा रहा है. Okay, you will see that the thickness of this strip will start decreasing because zinc will be getting lost in the solution to form zinc sulfate. And what you will observe is that the bluish tinge or the blue color turns to colorless. Okay, it starts turning to colorless. Why is this happening? Because zinc solid is getting converted into zinc 2 plus ions and copper 2 plus ions, which are converted into copper. Copper 2 plus ions were responsible for the color, but ये copper 2 plus ion को आप medium से हटा दे रहे हो and you are bringing zinc into the medium, and because of that this reaction involves the thickness of the zinc strip will decrease and the blue color of the solution will slowly turn into colorless. Okay, so in this reaction it is very simple to identify. Zinc changes into, gives out electrons, copper takes up electrons. Oxidation reaction इस तरह से लिखेंगे, ये reduction reaction हो गया. Now tell me something, in this reaction would I be getting electricity? मान लो कि एक hypothetical question ले रहे हैं, this is the setup, would I be getting electricity over here? बताइए, would I be getting electricity over here? Would I be getting electricity over here? Oxidation भी आपको मिल गया, reduction भी आपको मिल गया. Would I be getting electricity over here? No, a lot of people are saying no. Okay, a lot of people are saying no. The reason why it is not gonna show or we cannot observe electricity is because we do not have a wire, we do not have a circuit which can show movement of electrons. Okay, circuit complete नहीं है. हमारे पास एक circuit होना चाहिए जिसमें कि हम electrons के movement को show करें, and we take this redox reaction and when we put that thing in a particular design, हमारे पास एक wire होना चाहिए, movement of ions होने चाहिए, movement of electrons दिखना चाहिए. Only then I will be able to observe electrical current. Otherwise chemical reaction तो हो रहा है, redox reaction is also happening, but we would not be able to see electrical energy in action. We would not be able to see electrical energy in action. Okay, so please remember that just a redox reaction won't do. In this redox reaction, in this redox reaction, there are two terms that we obtain. One is known as reducing agent and one is known as oxidizing agent. A lot of people at times are confused with these two terms, और ये दोनों term बहुत easy है समझना. What are these two terms? Reducing agent, जो reduce कर दे. Agent means somebody who is provide. Agent आप क्या, delivery agent. Okay, when you say delivery agent, that means a person who is given the job of making a delivery of a particular item. Okay, railway agent, अगर आप टिकट बुक करना चाहते हो आप रेलवे एजेंट के पास जाते हैं क्योंकि वो बंदा आपका टिकट बुक करा देगा. Similarly, oxidizing agent is a entity which will oxidize something, Similarly, reducing agent is something which will reduce something. Now, अगर oxidizing agent oxidizes and reducing agent means it reduces. Okay, it reduces. Okay, reduces. So if something is oxidizing something else, तो वो खुद को क्या कर रहा है? If it is oxidizing something, okay, oxidizing agent is oxidizing something, oxidizes something by reducing itself. By reducing itself. Okay, खुद को reduce करके वो किसी और को oxidize करेगा. Similarly, if it is acting as a reducing agent, then it is reducing something by oxidizing itself. By oxidizing itself. Now, can you tell me what is undergoing oxidation over here? This is undergoing oxidation over here. This is undergoing reduction over here. So, which will function as the oxidizing agent? Which will function as the oxidizing agent? Please tell me. Which will function as the oxidizing agent? In this reaction, which will function as the oxidizing agent? अब बता सकते हैं? Yep. Anit, very good. Anything which is reducing itself will act as an oxidizing agent. So copper 2 plus, or I can say CuSO4 was acting as oxidizing agent. I can say that it is acting as an oxidizing agent. Similarly, what is zinc doing? It is reducing agent. अब आप ये बोलोगे कि okay, if you tell me that sir यहाँ पे तो Cu2+ दिया गया है, आपने यहाँ पे कॉपर सल्फेट क्यों लिखा? So यार हमेशा याद रखिए, there are certain ions जिनका बिहेवियर चेंज नहीं करता, जिनका केमिकल नेचर चेंज नहीं करता है. They are known as spectator ion. They are known, spectator means दर्शक. Okay, so कुछ केसेस में जैसे कि कल कल इंग्लैंड एंड न्यूजीलैंड की मैच थी. In that the players involved were the entities involved and they were spectators. So spectators रहे या नहीं रहे, गेम का एक रिजल्ट तो आना है. So copper sulfate means जो सल्फेट आयन है, that is a spectator. Okay, that's a spectator. So you put that or you don't put that makes no difference. Instead of sulfate, if there could have been something else, like nitrate ले लिया होता आपने और something else, कोई और आयन आपने ले लिया होता, उसको भी फर्क नहीं पड़ता, बिकॉज यहाँ पे रिएक्शन किसका हो रहा है? जिंक एंड कॉपर का. ओके, सो इट इज एन ऑडियंस डू नॉट अफेक्ट व्हाट इज हैपनिंग विद इन द रिएक्शन. दे you can remove that. So in electrochemistry you will see that we have removed spectator ions and we are only taking those entities which are participating in the reaction. Okay, only those entities participating in the reaction. So don't get confused. So Cu2 plus gains electron, it's working as an oxidizing agent, and zinc, loss of electron, is working as a reducing agents. ठीक है? So let's take a simple case. KMnO4 plus Fe2 plus changes to Mn2 plus Fe3 plus. Now in this reaction, which is acting as a oxidizing agent? What is the oxidizing agent? What is a reducing agent? पहली बात तो ये कि आप आइडेंटिफाई करना है कि ये redox reaction है या नहीं. So remember that this potassium over here is a spectator ion. It is a spectator because potassium's oxidation state is never gonna change. उसका oxidation state सिर्फ +1 रहता है. It can be +1 in a combined state. +1 के अलावे it will never ever have any other oxidation state. Manganese on the other hand has a oxidation state of +7. Okay, manganese has an oxidation state of +7. Iron has an oxidation state of +2, manganese +2 and iron +3. So +7 to +3, what is happening? +7 to +3, it is undergoing reduction, and +7 to +2 it is undergoing reduction, and +2 to +3 it is undergoing oxidation. Okay, oxidation. So whatever is undergoing reduction Can I call it, whatever is undergoing reduction, can I call it oxidizing agent? So permanganate को इसीलिए हम ऑक्सीडाइजिंग एजेंट बोलते हैं. Iron is undergoing oxidation, so I'll call it reducing agent. I'll call it reducing agent. Okay? I'll call it reducing agent. So whatever is undergoing reduction will be qualified as or will be characterized as an oxidizing agent. Whatever will be undergoing oxidation will be classified as a reducing agent. Iron reacts with oxygen, converts to Fe2O3. ये आप लोग रस्ट के केस में देखते हो. Okay, you see this happening within the process of rusting. Iron converts into its oxide. So iron is undergoing oxidation, oxygen is undergoing reduction. Iron is undergoing oxidation, oxygen is undergoing reduction. तो जो reduction कर रहा है, whatever is performing reduction, so iron oxidation, oxygen reduction. So whatever is undergoing oxidation, is giving electrons. और ये electrons किसके पास जाएंगे? These electrons will go where? To oxygen to reduce it. Similarly, oxygen is getting reduced because it is taking up the electrons that iron could have given. So iron is turning into a reducing agent, Fe reducing agent, and oxygen oxidizing agent. Okay? Yes, Divyanshu, we will be doing that, but we will be doing it in a systematic manner. Okay, we'll be doing that in a systematic manner. So this is all for today. What we have learned today is oxidizing agent, reducing agent, कहाँ पे कैसा free energy change होता है. Next class जो होगी, we will start with galvanic cells and then we'll move on to electrolytic cells. Okay, so first we will cover galvanic cells, Nernst equation, problems on Nernst equation, and then we will move to electrochemical cells. So please do join us for every session because electrochemistry master करना, अगर आपने master कर लिया, so all every year mains में almost 2 questions electrochemistry के रहते हैं. Okay, electrochemistry के 2 question हमेशा रहेंगे. So please review this lecture, come back in the next session, and also remember to bring a pen and a paper ताकि questions और whatever is being explained आप उसको जल्दी से समझ जाओ. Okay, so the last thing that I would say is please do like, share and subscribe our channel because always be updated with the awesome content that comes out over there. And this is Saurav Goswami signing off, and we will discuss voltaic cells or galvanic cells in the next class. Okay, bye bye guys and have a lovely time ahead.